other two custom attribute classes. So let's copy the appropriate declaration from one of our other custom attribute classes and appropriately paste the contents of our clipboards into our regular expression attribute class file. So now we have created 3 custom attributes implemented in 3 separate files. The first custom attribute we created is named required attribute. When this attribute is declared against an appropriate program element, this means that the associated input field must not be left empty. If it is left empty, the field value is deemed as invalid. The second custom attribute we created is named string length attribute. When this attribute is declared against an appropriate program element, this means the associated input field must contain a character length that falls within the boundaries defined by a specified minimum value and a specified maximum value. The third custom attribute we created is named regular expression attribute. When this attribute is declared against an appropriate program element, this means that the associated input field must contain a value that matches a specified regular expression pattern. So through the declaration of one or more of our custom attributes, a developer can express how a certain input field should be validated. Without the logic to implement the validation rules, however, these attributes are useless. These custom attributes perform no functionality other than to add metadata to relevant program elements. So the next step is to write the validation code. We must write the validation logic that correlates with each of our custom attributes. Through the use of reflection, we'll be able to read the metadata added to the relevant program elements through the use of our custom attributes. The use of our custom attributes is for the purpose of declaring how validation logic is related with relevant program elements, which are also related to relevant input fields. So let's write the relevant validation logic. So to do this, let's first add a new class named validation directly to the project node. So we want this class to be separate from our custom attribute classes. We are going to implement our own validation code in this class. So we first want to create the validation logic that corresponds to each of our custom attributes: the required attribute, the string length attribute, and the regular expression attribute. Let's encapsulate this functionality within 3 private methods. Let's first implement the validation logic that corresponds to the required attribute. So let's create a private static method named fieldRequiredIsValid that returns a Boolean value. This method contains one parameter. Let's name this parameter enteredValue and define it as a string. The logic for this method is basic. If the entered value passed into this method as an argument is not null or empty, return true, because this means the user has entered a value, which makes the input field entry valid. If the code that returns true is not executed, this means the entered value is invalid and false must be returned to the calling code. Let's implement the validation logic that corresponds to the string length attribute. The method signature for this method is the same as the fieldRequiredIsValid method, except we need to also pass in a field of type string length attributes to this method, in addition to the parameter representing the entered value. This is so that we can access the min length and max length public properties that we implemented for the string length attribute class. The values stored in these 2 properties are integral to the validation logic performed against relevant inputted values. Let's name this method fieldStringLengthIsValid. So to implement the validation code, let's implement an if statement where the condition evaluates the entered value argument to see if its character length is greater than or equal to the min length property and is less than or equal to the max length property. If the character length of the entered value argument falls within the range defined by the min length and max length property values, the entered value is valid, so we can return true to the calling code. If, however, the character length of the entered value does not fall within the specified range, we must return false because the entered value is not valid. So let's now implement the validation private method that corresponds to the regular expression attribute. So the method signature is almost the same as the field string length is valid method's method signature. Let's appropriately name this method field pattern match is valid. Instead of including a parameter of type string length attribute, let's include a parameter of type regular expression attribute. This is so that we can access the public property named pattern, which is a member of the regular expression attribute class. The pattern property will contain the regular expression pattern against which we need to validate the entered value. So let's use the regX class to perform our validation logic. This class is a member of the system.text.regularExpressions namespace, so let's include an appropriate using directive. The regX class contains a public static method named isMatch. We can use this method to validate the entered value against the relevant regular expression pattern. If the isMatch method returns true, this means the entered value is valid, so we must return true to the calling code. If, however, the isMatch method returns false, this means the entered value is not valid and we must return false to the calling code. Okay, so we have now implemented the validation logic that corresponds to our custom attributes. Let's create a public static method named propertyValueIsValid that returns a Boolean value. This method is responsible for calling relevant validation code that is relevant to a specific program element and a user inputted value. The validation code executed is determined by the custom attributes that have been declared against the relevant program element. In the interests of keeping this code simple, the code will only be relevant to a program element that is a property. So the first item in the parameter list for the propertyValueIsValid method is a parameter of type type. This parameter represents the type that contains properties against which our custom attributes may have been declared. For example, a user-defined type representing an employee record. The next parameter represents the value that a user enters, i.e., an input field, which is correlated to a particular property and needs to be validated by our code. This parameter is appropriately named entered value. The next parameter represents the program element, which will be a property in this case, that is a member of the type represented in the first parameter. So, for example, the program element could be the first name property, which is a member of a user-defined type named employee. The last parameter for this method represents the error message that will be displayed to the user if the user's input is deemed as invalid. We want to output the error message value, so let's include the out keyword in the relevant parameter definition. Let's implement the logic for this method. Firstly, let's get a reference to the relevant program element. So the program element in this example will be the property on which one or more of our custom attributes has been declared. So, for example, if we are validating the first name property on the employee user-defined type, the element name argument will contain the literal text first name, which is the name of the first name property. To get a reference to the user-defined type, in this case employee, the calling code would pass in type of employee. This means we can use reflection to inspect the relevant program element to ascertain which custom attributes have been declared against the relevant program element. Using reflection, we can then ascertain how we should validate the relevant entered value. So let's write code to get a reference to the relevant program element, which in this case will be a property. Reflection can be used to get relevant information about a program element. We want to know in our code what custom attributes have been declared against the relevant program element. So we can use the property info type, which is a member of the system.reflection namespace, to gain access to the property information that we need. We must include a using directive to the system.reflection namespace. Let's define a variable named prop as the property info type, and let's assign a value returned from a call to a method named getProperty, which is invoked on the type argument passed into the t parameter of this method. Note that we need to pass the element name argument to the getProperty method. The element name argument will store a reference to the name of the relevant property. We now have a reference to the relevant property information. We can use the getCustomAttributes method to return a collection of custom attributes that have been declared against the relevant property. We can assign the returned value to an array of type attribute. The getCustomAttributes method is returning a collection of type IEnumerable, and I want to store a reference to the relevant custom attribute objects in an array, so let's use links to array extension method to convert the IEnumerable collection into an array. Let's initialize the error message output parameter to an empty string. Let's write code to perform a for each loop and loop through each attribute object declared against the relevant program element. Then within the for each loop, let's implement a switch statement and use pattern matching code to get a reference to the relevant custom attribute objects so that we can perform appropriate validation on the entered value. So the switch statement evaluates the type of each relevant attribute object using pattern matching. Using pattern matching, we are able to get a reference to the attribute objects that have been declared against the relevant program element. This is the magic of pattern matching in action. Pattern matching was introduced in C# version 7. It allows the developer to write code to assess whether an object type matches the object type specified in a case statement. If there is a match, a reference to the relevant object is made available on the same line of the code as the case statement. So here we have case required attribute. If the object referenced by the attr variable is of type required attribute, the RA variable is assigned the value referenced by the attr variable. We are then able to use the RA variable in our validation code that resides within the relevant case block. So we can call the appropriate private method for validating required fields that we implemented earlier to validate the relevant user entered value. If the entered value is deemed as invalid, we can output an error message to the user through the error message output parameter, which has been appropriately marked with the out keyword, meaning we can output a value through this parameter to calling client code. If the relevant user input fails validation, we need the property value is valid method to return false. So let's include the other case statements pertaining to the other two custom attributes. So let's implement the case block for the string length custom attribute. And lastly, let's implement the case block for the regular expression custom attribute. Great. Let's write the calling client code. Let's go to the .NET Core Console project. Let's start by creating classes that can represent data models. The first model will be a class that represents an employee record. So let's create a new folder and name it Models. Let's add a new class named employee to the models folder. This class contains 6 auto-implemented properties: ID as int, first name as string, last name as string, phone number as string, email address as string, and postcode as string. Great. So we are now going to appropriately declare our custom attributes against the properties we have just added to the employee class. These attribute declarations will indicate to our validation code how the input values associated with the employee class's relevant properties should be validated. Let's include an appropriate using directive at the top of our code to the validation component.customattributes namespace. So let's apply the required attribute to the ID program element. Notice how when we declare our custom attributes, we don't need to include the attribute suffix. So even though the class representing the required attribute is named required attribute, when we declare the attribute against the relevant program element, we can omit the attribute suffix. So in this case, we can declare the attribute using the name required. Let's declare the string length attribute against the first name property. Let's pass appropriate values to the constructor of the string length attribute. So let's say the maximum character length for the first name input field should be 15. Our next argument is the error message we wish to output to the user if the user enters an invalid value for the first name field. For the last parameter, let's say the user must enter a value for the first name field that has at least 2 characters. Let's declare the required attribute against the first name property. So we can copy and paste the custom attributes declared against the first name property to the last name property. Now the phone number property will include the same attributes and settings applied against the first name and last name properties. But we also want to validate the phone number against a regular expression pattern that can be used to validate UK phone numbers. So let's navigate to this URL. I find this website very useful for finding regular expression patterns. Let's do a search for UK phone numbers. Let's copy an appropriate pattern from our search results. We can then appropriately pass this pattern as an argument to our regular expression custom attribute. So let's appropriately paste our pattern into our code. Note that we may need to include the @ symbol preceding the string references of the regular expression patterns. This is because the pattern may include backslash characters which need to be escaped because the backslash character is used by C# within strings for escape sequences. For example, the \n escape sequence denotes a new line within a string. The \t escape sequence denotes a horizontal tab character within a string, etc. So by including the @ symbol preceding the string, we are indicating that any backslash character should be interpreted as a literal backslash character and not as part of an escape sequence. So let's apply the custom attributes for the email address property. Let's find an appropriate regular expression pattern and appropriately paste it into our code. Let's do the same for the postcode address. Let's say we need the postcode to be a valid UK postcode. Great. So now let's build a basic front end so that we can test our validation code. Let's write a reusable private method that contains logic to prompt the user for a relevant field value. We need this code to run within an infinite loop, which we can implement using a do loop. Once the user enters a valid value, the code will break out of the infinite loop. The getInput method returns true once the user has inputted valid data for the relevant input field. We can use the out keyword to make the last field an output parameter where we can pass the valid data to the calling code. Let's go to the main method and implement the calling code. Let's instantiate an object of type employee. Let's ensure that we have a using directive to the attributes_examples.models namespace. Because of course the employee class is a member of this namespace. Let's create 3 local string variables: empid, first name, and postcode. We need to get a reference to the employee class's type. We can do this using the typeof method, like this. Let's write code to handle the user input for the employee's ID. So once the user has entered a valid value for this field, the valid data can be assigned to the ID property. The ID property of the employee type is an integer value. So let's write code to convert the relevant string value to an integer value. Let's write code to handle the user input for the employee's first name field. Once the user has entered a valid value for this field, the inputted value can be assigned to the first name property. Let's write code to handle the user input for the employee's postcode. So let's write code so that once the user has entered valid information for the relevant fields, a message stating that the user has now entered valid data for the relevant employee is outputted to the console screen. Great, let's test the code. So if we press the Enter key without entering an employee ID, we get an expected output. An appropriate error message is outputted to the console screen. Let's enter a valid ID. Great. So if we leave the first name field blank and press the Enter key, we get an appropriate error message outputted to the console screen. If we enter just one character for the first name field, the string length validation code deems our input as invalid and an appropriate error message is output to the console screen. So now if we enter a value for our first name field that contains a character length that falls within the character length range, which is between 2 and 15, this input is deemed as valid. If we leave the postcode field blank, we are presented with an appropriate error message. Let's enter a valid UK postcode. Great. Just to demonstrate that we are able to reuse our custom attributes on other user-defined types, let's create another model. Let's create a class to represent a department record. Let's apply some of our custom attributes. Let's go to our main method and test our code. In the interests of time, we'll only include the department short name field in our test here. Excellent. So let's use a predefined attribute that already exists in a .NET library. So the attribute I want to use is named JSON-ignore. So we want to add functionality to output our employee object to the console screen in JSON format. Using the JSON-ignore attribute, we can choose which fields to exclude from our employee object JSON output. Let's declare the JSON-ignore attribute against the phone number property and the postcode property. Let's go to our main method and write the code to serialize the employee object in JSON format. Let's run the code. And you can see that the JSON output does not include the phone number and the postcode fields. Great. Let's comment out the JSON-ignore attribute declarations so that we can include all of our property values for the relevant employee object in our JSON formatted output. Okay, so I accidentally inputted Bob's surname, which is Jones, for the postcode field, and I've noticed that there is a bug in our code. The error message format outputted to the screen is incorrect. the validation was run correctly, i.e. clearly Jones is not a valid postcode, but the error message itself is incorrect. The 0 wrapped in curly brackets in the appropriate code should serve as a placeholder for the property name of the property against which the relevant attribute has been declared. The 1 wrapped in curly brackets should serve as a placeholder for the regular expression pattern specified for the purpose of validating that a postcode entered by the user is in a correct UK postcode format. So I can see what is causing this issue. We need to remove the dollar symbol preceding the error message specified in this constructor. We want to use composite string formatting and not string interpolation for this string value. For details on composite formatting versus string interpolation, please view a video on C# strings created by this channel. A link to this tutorial is available below in the description. So let's repeat the input that we specified in the previous test. Great, the validation code is correct, and the outputted error message is also correct. Okay, but in our outputted JSON text here, the postcode field is null. So, it looks like we have another bug here. Oh right, so when I copied and pasted the code here, I forgot to change the relevant code so that the postcode property is set to the user's input. Okay, let's correct this. And let's test the code again. Excellent. We looked at how attributes are used in code to add metadata to program elements like classes, methods, properties, etc. And reflection can be used to read the metadata added through the use of the attributes at runtime. We discussed that there are 2 broad categories in C# for attributes, namely predefined attributes, which are built into the .NET base class libraries, and custom attributes, which allow the developer to implement the developer's own attributes by creating a class that inherits from the system.attribute built-in class, either directly or indirectly. We created code examples using predefined global attributes, namely assembly version attribute and assembly description attribute. This demonstrated how global attributes can be used to add and modify metadata at the assembly scope. We created code examples using predefined general attributes, namely conditional attribute, obsolete attribute, and attribute usage attribute. This demonstrated how we can add and modify metadata for program elements. We then created our own custom attributes as part of code logic used for the purpose of field validation. The use of reflection was also employed as part of this code logic. This code implementation imitates how the ASP.NET MVC framework uses attributes for field validation. I hope you've enjoyed this video on using attributes in C#. In the next part of this course, we'll create a basic ASP.NET MVC application where we'll use technologies like attributes, link, and entity framework along with front-end technologies like HTML, Bootstrap, CSS, and more. Please consider subscribing for more content on advanced C# topics and much more. And please ring the bell so that you'll be notified of future content. If you liked this video, please give it a thumbs up. It'll be greatly appreciated. Please feel free to share this video with anyone you feel may benefit from its content. I really enjoy reading your comments, so please feel free to engage with me in the comments section. As always, the code created for this video can be downloaded from GitHub. A link to the relevant GitHub repository is available below in the description. Hi and welcome to the 9th and final part of this Advanced C# course. I was going to end the Advanced C# course with an example of creating an ASP.NET MVC web application using C#. The more I delved into writing the tutorial on ASP.NET MVC, the more I realized that ASP.NET MVC at least demands its own video series. So I'm currently working on a video series where we'll build an ASP.NET MVC web application using C#. I'll bring these videos to you as soon as I can. As I had originally intended, I'm going to finish the Advanced C# course focusing on the topic of C# reflection. So let's get into it. Let's first gain a basic understanding of reflection, and then we'll write a code example using the reflection technology in C#. So, what is reflection? Reflection provides objects of type that describe assemblies, modules, and types. You can use reflection to dynamically create an instance of a type, bind the type to an existing object, or get the type from an existing object and invoke its methods or access its fields and properties. If you are using attributes in your code, reflection enables you to access them. For content like this and much more, please consider subscribing and please ring the bell so that you'll be notified of future content. If you like this video at any point, please give it a thumbs up. It will be greatly appreciated. In the 8th part of this Advanced C# course on C# attributes, we used the reflection technology to read metadata provided through the use of our own custom attributes from relevant program elements. When I say program elements, I'm referring to classes, methods, fields, properties, etc. So reflection allows the developer to access metadata within .NET assemblies at runtime. .NET assemblies are self-describing entities, which means the metadata data about the relevant assemblies reside within the assembly itself. So at runtime, we are able to load a target assembly and read its metadata using reflection. Using reflection, we are able to, for example, instantiate objects from classes that reside within the target assembly and invoke the relevant object's methods or get and set the relevant object's property values. So in this video, we are going to create a code example that will serve as a test harness. We are going to create code that loads a target assembly and displays a list of relevant classes that reside within the target assembly. We can then select an item in the relevant list that represents a class and test the functionality within each of the class's methods. The important thing to note here is that in this example, we will not reference the target assembly from within the project that contains our calling client code. We are using reflection to late bind to the classes that reside within the target assembly, so that we can instantiate objects and test the object's functionality at runtime. Note that when I refer to the target assembly, I am referring to the assembly that contains the functionality we wish to test through our test harness. We will be using what is known as late binding to test the methods that reside within the relevant classes contained within the target assembly. So, what is late binding? When we reference an assembly from a project through, for example, Visual Studio, and subsequently write code to instantiate an object from a class that resides within the referenced assembly, this is known as early binding. When we reference an assembly like this, the compiler has information about the target assembly at compile time. Late binding occurs when we don't set a reference to a target assembly at compile time, and we instantiate an object from a class that resides within the target assembly at runtime. The obvious disadvantage to late binding is that late binding is prone to runtime errors. When early binding is employed, the compiler has relevant knowledge, for example, relevant type information about the target assembly's constituents at compile time. So compile time errors can be flagged and corrected at compile time. Potential errors are averted at compile time, and therefore certain runtime errors are avoided. With late binding, reflection can be employed to gain necessary information about the target assembly itself and its constituents at runtime. So let's create our test harness code example where we'll use late binding to test the functionality that resides within a target assembly. Let's create a .NET Core Console application named Test Harness. Let's create a .NET Standard library project named Utility Functions. The Utility Functions project will be compiled into our target assembly. Now, it is important to note that I have included the Utility Functions project, which of course, when compiled, is compiled into a .NET assembly, in the same solution as the .NET Core Console project where we'll write our calling client code. This is important to note because we are not going to explicitly reference the Utility Functions assembly from the .NET Core Console project. So if we were to early bind to the Utility Functions assembly, we would reference our Utility Functions project like this. But let's cancel this dialog box because we are going to load the Utility Functions assembly at runtime using reflection. We are not going to set a reference to it at compile time. We want to late bind to the Utility Functions assembly at runtime. This is obviously just a mock example and not a real-world application. But you can see how we could put a number of assemblies within a directory, traverse the assemblies within the relevant directory, and automate the testing of functionality within the target assemblies at runtime. We would not have to reference any of these assemblies within our test harness project, because using reflection, we can access all the information we need for each assembly and test the functionality within the assemblies. So the advantage of this loose coupling of our test harness application with the assemblies that we are testing is that we don't need to early bind to the assemblies at compile time. We can simply put an assembly or assemblies in an appropriate directory, and our test harness application can learn about the assembly or assemblies at runtime by accessing the relevant assemblies metadata at runtime through reflection. But we will simplify this example and focus on classes within a particular namespace within one target assembly. Our target assembly in this case will be the Utility Functions assembly. If this doesn't make sense to you at the moment, please bear with me, and this will become clearer as we progress with creating this code example. Let's include basic functionality within our Utility Functions project. Once completed, this project will be compiled into an assembly which will serve as our target assembly, i.e., the assembly against which we'll perform our reflection functionality. Through the use of reflection, we'll be able to read relevant information about the assembly, instantiate objects from its classes, and test its methods. So, let's write the code for the Utility Functions assembly. Let's start by deleting the class that was auto-generated by Visual Studio. Let's add a class named Basic Utility Functions. Within the Basic Utility Functions class, let's create 4 very simple methods. Let's create a method named WriteWelcomeMessage. The WriteWelcomeMessage method contains no parameters and returns a welcome message as a string. Let's write a method named integer+integer. The integer+integer method contains 2 integer parameters and returns an integer value. The returned integer value will be the mathematical result of the first integer argument plus the second integer argument. We can appropriately name our parameters operand 1 and operand 2, respectively. Let's write a method named concat3strings. This method contains 3 string parameters and returns a string value. The returned string is a concatenation of the arguments passed into the concat3strings method. The order in which the string arguments are concatenated is the order in which their corresponding parameters appear in the relevant parameter list, from left to right. Let's write a method named getStringLength. It contains 1 string parameter. This method returns an integer value, the character length, of the string argument passed into the getStringLength method. And that's it. That is our very basic utility functions class completed. Let's create another basic class. Let's name this class Basic Math Functions. Let's create 2 really simple methods in this class. Let's create a method named divideOperation, which contains 2 parameters of type double. This method returns a value of type double. That is the result of a divide mathematical operation. In this method, the second argument is divided into the first argument, and the result of the divide operation is returned to the calling code. Let's create a method named multiplyOperation, which contains 2 parameters of type double. This method returns a value of type double. That is the result of a multiplication mathematical operation where the first number argument is multiplied by the second number argument. The returned value will be the product, which of course is the result of the multiplication of the first number argument by the second number argument. Okay, so we now have 2 classes in our utility functions project. So now we want to be able to decorate certain program elements with a custom attribute that we can use to provide additional information to the calling code about the relevant program elements. In this case, the program elements will be classes and methods. Let's create a custom attribute named Information Attribute. For more information on custom attributes, please view the previous part of this course, which is a tutorial entitled C# Attributes. I have included a link to the relevant video below in the description. So, in order to create a custom attribute, the relevant class must inherit from the system.attribute built-in class. Let's keep this class really basic, so let's add 1 auto-implemented property named description. This property will enable us to provide a custom description about a program element that we'll decorate with our information attribute custom attribute. We want to constrain our information attribute custom attribute to the decoration of only class and method program elements. So we can do this by decorating our information attribute custom attribute class with the attribute usage built-in attribute. We can then pass the following bitwise operation to the constructor of the attribute usage built-in attribute. So let's pass attribute targets.class or attribute targets.method to the constructor of the attribute usage built-in attribute. So this means that only classes and methods can be decorated with our information attribute custom attribute. So next, let's apply our custom attribute to the relevant classes and methods. Let's go to the basic utility functions class and let's decorate the class itself and its methods with the information attribute custom attribute. So let's set the description property for our custom attribute declared against the basic utility functions class to this class contains basic utility methods. Let's set the description property for our custom attribute declared against the writeWelcomeMessage method to this method returns a welcome message. Let's set the description property for our custom attribute declared against the integer plus integer method to this method returns the sum of 2 integer operands. Let's set the description property of our custom attribute declared against the concat3strings method to this method concatenates 3 strings in the same order as they appear in the parameter list from left to right. let's set the description property for our custom attribute declared against the getStringLength method to this method returns the character length of a string argument. So let's move on to our basic math functions class. Let's decorate the basic math functions class with our information attribute custom attribute like this. So here the description property is set to this class contains basic math functionality. Let's decorate the divide operation method with our custom attribute, where the attribute's description property is set to this method divides the first number by the second number and returns a result of this divide operation. And lastly, let's decorate the multiply operation method with our custom attribute and set its description property to this method multiplies the first number by the second number and returns a result of this multiplication operation. So we have included in the metadata for our utility functions assembly very basic descriptions about method and class program elements through the use of our information attribute custom attribute. Now let's write the calling client code. So in the calling client code, we want to provide functionality that targets a particular namespace within the target assembly. In this case, our target assembly will be the utility functions assembly and reads all the relevant information about the assembly's classes and methods that are members of the relevant namespace. We'll create functionality where the user can choose a class from a list of classes that reside within the relevant namespace. Once the user has chosen the class that the user wishes to test, the user can then choose a method from a list of methods that are members of the relevant class. The user can then select from a list of methods the method that the user wishes to test. Once the user has chosen the method that the user wishes to test, the user is prompted for values for each of the parameters contained within the relevant method's method definition. Once the user has provided values for all the relevant parameters, our code will invoke the method, and the result returned by the method is displayed to the console screen. So you can see that this test harness application can be used to test functionality within an assembly. Note that you can extend the code that we are about to write to traverse a number of assemblies within a directory and automatically test particular functionality within the assemblies. So you could write your own automated test facility based on the code we are about to write. For the purposes of this tutorial, however, the code will be simplified. So let's write the code for our test harness project, which is our .NET Core console project. The first thing to do is within our calling client code is include a using directive to the system.reflection namespace, like this, so that we can make use of reflection in our application. So let's start writing our code in the main method. Let's first create two local string constants. The first constant stores the target assembly file name, utilityfunctions.dll. The second constant stores the target namespace that contains the classes that the user will be able to test through our test harness application. So the namespace is utility functions. Let's write the code that will load the target assembly at runtime. So we are using the assembly.load method to do this, but we may need to replace this with the assembly.loadFile method. When we test and debug the code later in the tutorial, we'll know which method needs to be employed here, either the load or loadFile method. So we'll leave it as load at this point. We pass in the path of where the target assembly will be in order to load the target assembly into memory. So later in this tutorial, just before we test our code, for the sake of simplicity, we'll copy the target assembly into the same directory as where the assembly for this project will reside. So let's write code here to point to the path of the target assembly, which will be the current directory, the same directory as where the test harness assembly will reside. Let's use the path.combine method to combine a path with the name of the file. The path class resides in the system.io namespace, so let's include a using directive to the system.io namespace. So we are able to get the current path from the appdomain.currentdomain.base directory property. This is the directory where the assembly that we are currently working on will reside. Let's pass this value as the first argument to the path.combine method. Then let's pass the name of our target assembly, which is utilityfunctions.dll, as the second argument into the path.combine method. The return value from the assembly.load method will be the object of type assembly. So let's assign a variable of type assembly, the value returned from the assembly.load method. So we have now got a reference in memory to our target assembly. Let's write code to get a list of classes from the target namespace within our target assembly. So the namespace within our target assembly is named utility functions. So let's use link to get a list of types or classes from within the utility functions namespace. Let's ensure that we have a using directive to the system.link namespace. So we can use the assembly object's getTypes method to return a collection of classes that reside within the target assembly. We can use the where method to filter on the assembly's utility functions namespace, like this. Let's assign the returned result to a generic list that is strongly typed as system.type. Then let's convert the IEnumerable collection returned by the link query to a list, and we can do this by using the toList conversion method, like this. Let's write a method that encapsulates writing a prompt to the user. Let's write code to display a message prompting the user for input to the console screen. As you can see, we are prompting the user to press a number key to indicate to the application which class the user wishes to test. So it is better to encapsulate this prompting functionality in a method that we can reuse for this purpose throughout the creation of this application. This method encapsulates the functionality of displaying text to prompt the user for input to the console screen. So next we want to write code to display a list of classes to the console screen so that the user can select the class that the user wishes to test. So we can simply write code that traverses the items stored in the classes list, which contains the result of our link query, and output the relevant class names to the console screen in sequential order. So let's do this. In our list of classes, each class name is preceded by a number, which will allow the user to press a number key to select the class that the user wishes to test. Let's write the code where the user can press a number to select a class from the classes list. Let's use a switch statement to return the relevant item from the list. So now we want to create an object instance from the user's chosen class or type. We can use the activator.createInstance method to do this. And here we are writing code to late bind to a class within the target assembly. We can assign the returned object from the activator.createInstance method to a variable of type object. You can see that when we late bind like this, we do not have the benefits of type safety. So code like this is prone to runtime errors. This highlights a disadvantage of late binding like this in code. So because at compile time, we don't know the type that will be returned at runtime by the activator.createInstance method, we need to use a variable of type object to reference the returned value. So we have now written the code enabling the user of our application to choose a class from a list of classes by pressing a number key associated with the relevant class. Once the user has chosen a class, the user will be presented with a list of relevant methods. Let's write code to clear the screen once the user has chosen the class from the list of classes. Let's write a method where we can encapsulate code to output a heading to the console screen. On the screen that displays a list of methods belonging to the class that the user has selected, we want to include a heading at the top of the screen containing the class name that the user has chosen. Let's go to the main method and write the code to output the relevant heading to the console screen. Let's write code to prompt the user to choose from a list of relevant methods. We now want to write code to output a list of relevant methods to the console screen. So logically, the code to present the user with a list of methods is exactly the same as the code that presents the user with a list of classes. So we have an opportunity here to refactor our code by creating a reusable method that encapsulates functionality to output a list of both classes and methods. So this will be one block of code that can output a list for both classes and methods. In this method, we need to account for the difference between the type representing a class and the type representing a method. In this context, classes are of type system.type and methods are of type methodinfo. So to solve this problem, we can apply generics. Let's create a method named displayProgramElementList. Let's include the t placeholder between greater than and less than symbols to indicate that this is a generic method. Let's base the code for this method on the code that we have already written in the main method to output a list of classes. You can see that we are writing this code in a more generic style because this code will output the items of a generic list that is strongly typed as system.type and a generic list that is strongly typed as methodinfo. Great. So let's replace the code in the main method that outputs a list of classes with a call to our displayProgramElementList method. The type that represents a class in terms of reflection is system.type. We have another opportunity to refactor our code because the code to return an object of type system.type from our list of classes or types logically is the same as the code to return an item of type methodinfo from a list of methods. So let's write code to encapsulate this functionality in a method named returnProgramElementReferenceFromList. So we need to include generic functionality within the method definition of the returnProgramElementReferenceFromList method. We also need to return a value of type t from this method. And we can copy the code for this method from our main method and paste it into our returnProgramElementReferenceFromList method. So let's replace the code in our main method that enables a user to choose from a list of classes with a call to the returnProgramElementReferenceFromList method. So let's call the getMethods method on the typeChoice object, which represents the class that the user has chosen from the relevant list, and assign the returned value to a generic list that is strongly typed as methodinfo. Note that a generic list that is strongly typed as system.type is used to store references to classes or types, and a generic list that is strongly typed as method info is used to store a list of methods. We can now reuse the display program element list method in our main method to display a list of methods. We can pass in the method info type to the relevant type parameter, but we don't actually need to do this here because the compiler has enough information to determine the type. Let's call the return program element reference from list method, which will enable the user to choose a method from a list of methods displayed to the console screen. Let's write an if statement to check if the method info object returned from the return program element reference from list method is not null. Let's write code to clear the screen. Let's write code to output a heading containing the class name and the method name of the class and method that the user has chosen to test. So the next step is to prompt the user to provide a value for each parameter of the relevant method. So we are able to get a list of parameters from the relevant method by implementing the method info object's getParameters method like this, and we can assign the returned result to an array of type parameter info. The next step is to invoke the method chosen by the user and pass in the relevant parameter values that will be provided by the user's input, i.e. if the relevant method contains any parameters. If the relevant method does not contain any parameters, the method can be invoked without any arguments passed to it. So let's encapsulate the functionality for this in a method named getResult. In order to execute the functionality for the getResult method, we need the relevant class instance object, the relevant method info object, and the array containing the relevant array of parameter info objects. So in the getResults method definition, let's include a parameter of type object to accommodate the class instance. Let's include a parameter of type method info to accommodate the relevant method to be executed. And let's include a parameter that accommodates an array of type parameter info. So the invocation of our method is going to be different in terms of code implementation when the method that is invoked requires a number of arguments, to when the method requires no arguments passed to it, i.e. the relevant method's method definition contains no parameters. So let's create an if statement that checks to see if the parameter's argument contains any items. If it does not contain any items, we can call the method info object's invoke method and pass null into the second argument. The first argument must be passed an argument that references the appropriate class instance. This class instance or object contains the method that we are invoking here through this line of code. The else part of the if statement invokes a method that does contain parameters. So we must write code to prompt the user for a value for each parameter. So let's create a method that allows for an argument which will contain an array of parameter info objects to be passed to it. So let's name this method return parameter value input as object array. Let's create a one-dimensional array named param_values and provision the array to hold a number of items equal to the number of items stored in the array passed into this method, i.e. the array of type parameter info. Let's create a counter variable named itemCount and initialize it to a value of 0. Let's create a for each loop to loop through each item in the parameters array. Let's write codes to prompt the user to enter a parameter value. So let's say that we know that the parameter type can only be one of the following: string, int, or double. So let's write an if statement to check the type of the relevant parameter. If the parameter is a string, then no type conversion of the console.readLine method value is necessary because this method returns a string. So we can then write code to assign the user's input to the relevant position in the parameter values array. So the code for when the relevant parameters of type int or double is slightly different. We must include an explicit type conversion from string returned by the console.readLine method to the relevant type before assigning the inputted value to the appropriate position in the param values array. We must increment the item count variable by 1 for each iteration of the loop. In the location in our code editors where the loop has exited, we can write the code to return the param values array to the calling code. Great! So let's go back to the getResult method and call the return parameter value input as object array method. Then we can write code to invoke the relevant method and pass in an array argument containing the user's input for each parameter as the second argument to the method.invoke method, like this. As stated earlier, the first argument passed to the invoke method is the relevant instantiated object, instantiated from the class that the user has chosen to test. To finish this method off, let's write the code to return the result returned by the relevant method to the calling code. Let's then go to the main method and call the getResult method. Let's write the code to display the returned result from the getResult method to the console screen. Great! Before we test the code, let's compile our two projects. Let's find the target assembly and let's copy the assembly to our clipboards. Then let's go to the directory of our test harness project and paste the target assembly into this directory. Let's test our code. Okay, so we have a little bug here. So I suspect this is because we need to use the load file method instead of the load method. So let's change the code accordingly. Let's run the code again. Great! We can see our classes displayed in a list, but our information attribute custom attribute class is also present in the list, and this is not desirable. We don't have any methods in the information attribute custom attribute class to test. So, if we select one of the classes that we wish to test, like, for example, the basic utility functions class, we are presented with a list of methods, which is great. There are some methods listed here that we are not interested in testing, like, for example, the equals method or getHashCode method. These methods belong to the object class, which, as we know, is ultimately the base class for all types in C#. So we only want to test the methods that perform functions directly related to the class we have selected, in this case, the basic utility functions class. We'll modify the code to filter out undesirable code elements in a bit. For now, let's continue with our test. Let's select the integer plus integer method. Oh, we should be receiving a prompt to enter a value for each of the parameters contained within the integer plus integer method. So we have another bug to fix. So here's where we need to fix the bug. I forgot to include the prompt text in the return parameter value input as object array method. So let's include a prompt for each parameter item. Let's test the code again. Let's select the basic utility functions class from our list of classes. Let's select the integer plus integer method. So we are now prompted to enter a value for the first parameter. Great. So let's do that. Let's enter 5 We are then prompted to provide a value for the second parameter. Let's enter a value of 6 for this parameter. Once we press the Enter key, the correct result of 11 is presented to us. Great! So, except for the fact that certain program elements that we have no desire to test are appearing in our lists, the basic functionality of our test harness is working as expected. So let's write the code to filter out those unwanted program elements. We are going to use the information attribute, custom attribute, for this purpose. Let's say that we only want those program elements that are decorated with our information attribute, custom attribute, to appear in our lists of program elements to test. So let's write a method that checks to see if a program element, i.e. a class, or a method is decorated with the information attribute, custom attribute. If the program element is decorated with the information attribute, custom attribute, we want to include the relevant program element in our list of program elements to test. If, however, the program element is not decorated with the information attribute, custom attribute, we must exclude the relevant program element from our list of program elements to test. So let's write a private static method named hasInformationAttribute. And let's include one parameter within its method definition. This parameter will represent the program element that we need to check. So we need the hasInformationAttribute method to check if the information attribute, custom attribute, has been declared against the relevant program element. In the context of the requirement of this application, the program element can either be a class or a method. So the parameter must be of a type that can accept a class or a method as an argument. In this particular case, those types will either be of type system.type or of type method.info. We could include two methods named hasInformationAttribute and differentiate their method definition, where each method definition contains a parameter of a different type. One version of the hasInformationAttribute method can contain a parameter of type system.type, and the other version of the method can contain a parameter of type method.info. So we could use method overloading to perform the desired check for if a custom attribute has been declared against a program element, i.e. either a method or a class. However, we can achieve what we want with only one version of the hasInformationAttribute method, because the system.type and method.info types both inherit from a common class, the member.info class. If we right-click the text in our code editors representing the type class and select Go to Definition, we can see that the type class inherits from the member.info class. If we do the same thing against the method.info class, we can see that the method.info class also inherits from the member.info class. If we look at the member.info class definition, we can see that it contains a method named getCustomAttributes, and this is the method we need to use to check if the relevant program element is decorated with the information attribute custom attribute. So the point is we don't need to overload the hasInformationAttribute method. We can simply define the parameter for the hasInformationAttribute method as member.info in one method. This will mean we can pass both types of arguments to the hasInformation method, i.e. an argument of type system.type, a class program element, or an argument of type method.info, a method program element. So let's look at the code for the hasInformationAttribute method. We have created a local string constant to store the name of the type of our information attribute custom attribute. So this name includes the namespace of where the information attribute custom attribute resides, a full stop, and the attribute class name. We have written code to loop through all the custom attributes that may be declared against the program element type passed into this method. As you can see, we are able to call the getCustomAttributes method for both class and method program elements in our method, because the system.type class, which represents class program elements, and the method.info class, which represents method program elements, both inherit from the member.info class, which contains the getCustomAttributes method. Within our for each loop, we first get the type of the current attribute. So we have written typeAttrib equals attrib, the current attribute object, dot get type. We then check to see if the name of the type attribute is equal to the information attribute custom attribute's name. If it is, this means that the information attribute custom attribute has been declared against the program element type passed as an argument to this method, so we can return true to the calling code. If all attributes have been traversed and none of the attributes match our information attribute custom attribute, this means that the program element passed as an argument to the method does not have our information attribute custom attribute declared against it, so we must return false. So this method can be used in our calling code to filter out program elements based on whether or not the relevant program element is decorated with the information attribute custom attribute. So how can we use our method for this purpose in our main method? The answer is we could modify the relevant link queries to include our hasInformation attribute method. And we can include our hasInformation attribute method in the relevant where filters. So let's first modify the link query for returning a list of class program elements. We can simply include a call to our hasInformation attribute method in the where filter method like this. To filter out methods that aren't decorated with the information attribute custom attribute, we can modify the appropriate link query like this. Let's test our code. Excellent. You can see that only those classes in our target assembly that are decorated with the information attribute custom attribute appear in the relevant list. If we select the basic math functions class from our list of classes, we can see that its methods that are not decorated with the information attribute custom attribute have been filtered out of the relevant list. Great! Let's also include functionality to appropriately output to the console screen the description property value of the information attribute custom attribute for our relevant program elements. In terms of the user's experience, this functionality will provide additional information about the classes and methods that the user wishes to test. So let's write a private static method named returnInformation custom attribute description. This method returns a string and contains a parameter of type memberInfo. Remember, both the system.type class and the methodInfo class inherit from the memberInfo class, so this method can be reused for both class and method program elements. We want to read the description property, so let's create a local string constant that references the text description. Let's create a for each loop that loops through the custom attributes that may have been declared against the relevant program element, which in this case will either be a method or a class. So within the loop, let's reference the attribute type like this. We can then apply an if statement to check if the current attribute is the information custom attribute. Okay, so let's refactor our code here so that the target information attribute type constant can be accessed from both this method and the hasInformation attribute method. If the current attribute is the information custom attribute, then let's access its description property. We can do this using a reflection like this. So we are attempting to check if the property info object is not null, but the compiler is complaining. This is because the project is currently built on .NET Core version 3.1. Checking for nulls like this is only allowed in a later version of C#. So I'm going to change the version of .NET to .NET 5 for this project. Great, and you can see now that this line of code is now supported, i.e. using the isNotNull line of code. But I'm going to use the old way of checking for nulls anyway, just in case the followers of this tutorial are using an older version of .NET for their projects. So we have now written the code to read the description property from objects derived from the relevant information custom attributes that have been declared against relevant class and method program elements. So let's write the code to appropriately output the program element descriptions declared through the use of our information attribute custom attribute to the console screen. Let's create a method named displayElementDescription for this purpose. This method only needs one parameter, which will be the text we wish to output to the console screen. Let's write code to check if the argument passed to this method is not null. If it is not null, let's write its value to the console screen using a different background and foreground color to the default console screen colors so that the text stands out. Then let's use the console.resetColor method to reset the color back to the default console foreground and background colors. Let's go to the main method and use the displayElementDescription method to output the relevant program element descriptions to the console screen. So we can pass the result of the return information custom attribute description method into the displayElementDescription method on one line like this. This code will display our custom descriptions of the program elements that the user wishes to test. Let's test the code. Okay, so we are getting a bug, and this is because the loadFile method cannot find the target assembly. The reason for this is because when we changed our version of .NET for the Test Harness project, a new directory for .NET 5 was created. This directory contains the assembly for the Test Harness project, but it doesn't, of course, contain the target assembly. So let's copy the most recently built utility functions assembly to the Net 5.0 directory. Let's run the code again. And you can see that our custom elements are displayed, and we are able to test the functionality of methods and classes that reside within our target assembly. We have used the reflection technology to accomplish this. You can also see that additional information about the relevant program elements is outputted to the console screen. This was made possible through the use of our information attribute custom attribute. Excellent! To finish off the application, let's add code to enhance the user's experience. As you may have noticed, once the user has tested a method, the application automatically ends. We currently have no way of navigating back to the first screen where we are presented with a list of classes that we may wish to test. We want the user to have the option of returning to the list of classes so that the user can carry on testing other classes and methods. So we can do this by putting the relevant code within an infinite loop. Once the user has tested a particular method, the user can either press, let's say, the spacebar key to end the application, or any other key to return to the screen that contains a list of classes. Let's test the code. Excellent. So the last thing I'd like to bring to your attention is the technology encapsulated in the system.reflection.emit namespace. Using this technology, a developer is able to generate code dynamically. So the developer is able to generate dynamic methods or even dynamic assemblies on the fly. The user could, for example, generate intermediate language code on the fly based on user input. So because of functionality like this, you can see how incredibly powerful the C# language is. I recommend navigating to this location to read more about this powerful aspect of reflection. I hope you've enjoyed this tutorial on C# reflection. We have now come to the end of this advanced C# course. If you've got this far, congratulations. This channel now provides 2 complete in-depth courses on features of the C# language, a beginner's course and an advanced course. The next series of videos will focus on the ASP.NET MVC framework, where we'll build an application in C# using the ASP.NET MVC framework on .NET 5. During this time, I will also produce other videos relating to C# and other technologies. So let's end this video by summarizing what we have learned about C# reflection. Reflection provides objects of type that describe assemblies, modules, and types. You can use reflection to dynamically create an instance of a type, bind the type to an existing object, or get the type from an existing object and invoke its methods or access its fields and properties. If you are using attributes in your code, reflection enables you to access them. We demonstrated using reflection to create an application that can serve as a test harness. The test harness allows the user to add a target assembly to the same directory where the test harness application resides, and choose a class that the user wishes to test from a list of classes that belongs to a specific namespace that resides within the target assembly. When the user selects a specific class from the class list, that class is instantiated into an object through the use of late binding. This is how the test harness is able to test the functionality within a target assembly without referencing the target assembly at compile time. In the test harness application, reflection is employed to instantiate the relevant class into an object. When an assembly is referenced by a project at compile time, this is known as early binding. With early binding, the compiler has relevant information about the types within the target assembly at compile time. Late binding is used when the compiler does not have compile time knowledge of the target assembly. So, a technology like reflection is used to access the relevant information about the assembly, which allows for late binding to occur at runtime. It was noted that late binding has the disadvantage of being prone to runtime errors. When early binding is employed, a specific type can be instantiated into an object, using the new operator, and we have the advantage of compile time type safety. We do not have the advantage of compile time type safety when late binding is employed in code and the activator.create instance method is used to instantiate an object from a type. Lastly, we briefly discussed the technology encapsulated within the system.reflection.emit namespace. Functionality for generating intermediate language code or IL code dynamically resides within the system.reflection.emit namespace. A developer can use the functionality within the system.reflection.emit namespace to create code for dynamically generating methods and even assemblies at runtime. For content like this and much more, please consider subscribing and please ring the bell so that you'll be notified of future content. If you like this video, please give it a thumbs up. It will be greatly appreciated. Please feel free to share this video with anyone you feel may benefit from its content. I really enjoy reading your comments, so please feel free to engage with me in the comments section. The code created in this tutorial can be downloaded from GitHub. A link to the relevant GitHub repository has been included below in the description. Thank you, and take care. Let's go back in time to the end of February 2002 with the first release of the .NET framework. This is when C# was first released. It is a new, fully object-oriented general-purpose programming language. Visual Basic, through its .NET evolution, has been upgraded from a largely event-based language tightly coupled with the Visual Basic 6 IDE to a new object-oriented version of itself called Visual Basic.NET. A managed version of C++ could also run within the .NET sphere. New languages like F#, which was first released in 2005, could also run within the .NET environment. These languages are all interoperable, which essentially means, for example, a C# application can consume a .NET component written in Visual Basic, or an application written in Visual Basic can consume a component written in C#. What makes this possible is the Common Intermediate Language, or CIL. All high-level .NET programming languages like C#, Visual Basic, C++, etc. are first compiled into the Common Intermediate Language before further compilation into machine language by the Common Language Runtime. All code that runs within the .NET runtime is considered managed code. The .NET runtime also makes available a number of libraries that can be leveraged by our custom .NET code. This is essentially done through a library of files called the Framework Class Libraries, or the abbreviation of this, FCL, which provide generic functionality for our applications to consume. The Common Language Runtime, or CLR, can be described as the .NET virtual machine and provides services like just-in-time compilation, memory management, security, and exception handling. It is important to note that the .NET framework will only run on appropriate Windows operating systems and must be installed in its entirety on the target computer. There have been many versions of the .NET framework released since its inception, and they are able to run side by side on the same computer. The latest version of the .NET framework at the time of writing this tutorial is .NET Framework version 4.7. Let's go back in time again, to June 2016, when the first stable version of the .NET Core runtime was released. It can be described as a cross-platform, more agile, modularized, lightweight version of the .NET framework. It supports appropriate standards so that multiple languages can run and be managed within the .NET runtime, and also provides language interoperability. Each .NET Core language compiles into the Common Intermediate Language, or CIL. .NET Core provides some of the standard framework class libraries, which can be called the Core FX and can be described as a partial fork of the framework class libraries. .NET Core's virtual machine can be referred to as Core CLR or Core Common Language Runtime, and it provides services like improved just-in-time compilation, memory management, security, and exception handling. Unlike the .NET Framework, .NET Core can run on Mac OS, Linux, as well as Windows. .NET Core also provides a modular framework so that only the modules that your application uses are shipped with your application. An important difference between .NET Core and the .NET Framework is that you no longer need the entire .NET Framework installed on the target computer, but only those components of the .NET runtime that your application needs. This is why .NET Core is often referred to as a more agile version of the .NET Framework. .NET Core is open source software which makes things like the bug fix release process more efficient. It is optimized for the cloud. It is designed for high performance, provides a great base for microservice architecture, it is designed to be highly scalable. .NET Core is definitely a significant evolution of the .NET runtime, but it must be noted that it does not replace the .NET Framework. Please see in the description below a URL for a Microsoft Docs webpage containing recommendations for when to use the .NET Framework and when to use .NET Core as the .NET runtime for your server applications. .NET 6 completes the unification of the platform and adds new capabilities for building web, native and hybrid apps for Linux, Windows, Mac, iOS and Android with a single code base. This video is an overview of what to expect with the release of .NET 6, which is due to be released on the 9th of November of this year, 2021. For content like this and much more, please consider subscribing, and please ring the bell so that you'll be notified of future content. Please feel free to share this video with anyone you feel may gain value from its content. Before I give a brief summary of what new features and improvements to expect with the release of .NET 6, I'd like to present you with a brief summary of my personal experiences as a developer with the technological innovations that have been made over the years. I remember working as a young developer in the late 90s on enterprise web applications. When I look back, I'm proud of what we were able to achieve using what is now known as Classic ASP, or Classic Active Server Pages. Classic ASP was introduced as Microsoft's first server-side scripting technology for creating web applications. The ASP files were coded in VBScript. I remember we wrote our business logic in Visual Basic and compiled our code into COM components. We then installed our COM components in an environment known as MTS, Microsoft Transaction Server. The Microsoft Component Object Model, COM, and Microsoft Transaction Server, MTS, later evolved into COM+. Using Active Server Pages, our code was written in VBScript, and we would call our COM components from our Active Server Pages. COM+ handles many of the resource management tasks that previously needed to be programmed by the developer, such as thread allocation and security. Classic Active Server Pages allowed a developer to implement code logic using VBScript and output HTML, client-side JavaScript, and CSS code to the client's browser. So back then, we typically created our applications using a 3-tier architecture. Classic ASP contained code and logic to output HTML code, JavaScript, and CSS to the client's browser. COM components that contained business rules ran in MTS, later known as COM+. SQL Server was used for our backend storage facility. In the early 2000s, I moved to London. My move to London coincided with the first release of C# and .NET. .NET was a gigantic step forward for Microsoft technologies. Visual Basic 6 was the last version of Visual Basic before the dramatic change that was to follow in the form of .NET. .NET was a complete rethink. Visual Basic was still offered as a language, but instead of being limited to being a largely event-based language tightly coupled with the Visual Basic 6 IDE, was now known as Visual Basic .NET and is a fully object-oriented programming language. The first version of .NET was named .NET Framework. Programs written in .NET Framework executed in a software environment, in contrast to a hardware environment. This software environment is named the Common Language Runtime, CLR. A number of class libraries, called the Framework class libraries, are built into .NET Framework and are available to be consumed by .NET applications. Developers can produce their software by combining their source code with .NET Framework class libraries. So .NET Framework provides a library of classes that can be leveraged from our applications. .NET applications run in an environment known as the Common Language Runtime, or CLR, which can be described as the .NET virtual machine and provides services like just-in-time compilation, memory management, security, and exception handling. So .NET Framework provided developers with a sophisticated environment that would revolutionize the developer's experience. In the early 2000s, I was now working on web applications using a .NET version of Active Server Pages, known as ASP.NET. And I was able to write my code using a new, fully object-oriented programming language known as C#. So, in the early 2000s, the introduction of .NET was a massive leap forward. .NET Framework was interoperable, meaning you could write code in any language that supported the Common Type System. So we could write our applications using, for example, C#, Visual Basic, C++, etc. This was great, but .NET Framework could only run on Windows platforms and required a monolithic installation. .NET Framework does not run on Linux or Mac OS. Mono was released on June 30th, 2004. Mono is a free open-source implementation of Microsoft's .NET Framework based on the ECMA standards for C# and the Common Language Runtime. Mono was a version of .NET that could run on multiple platforms. Mono can run on Windows, Mac OS, and Linux. On June 27th, 2016, the first version of .NET Core was released. .NET Core is the .NET successor to .NET Framework. .NET Core is primarily developed by Microsoft employees by way of the .NET Foundation and released under the MIT license. .NET Core supports the use of NuGet packages. .NET Core can be described as a lightweight, modular, cross-platform, and more agile version of .NET Framework. To prevent future fragmentation of .NET implementations, .NET Standard was introduced. The motivation behind .NET Standard was to establish greater uniformity in the .NET ecosystem. .NET Standard is a formal specification of .NET APIs that are available on multiple .NET implementations. The specification is maintained by .NET implementers, specifically Microsoft includes .NET Framework, .NET Core and Mono, and Unity. .NET 5 was a significant release of .NET and was released on the 10th of November 2020. .NET 5 is the first release of a version of .NET that attempts to unify all features of all versions of .NET under one implementation of .NET. The idea behind this version of .NET is to have one .NET moving forward that can target Windows, Linux, Mac OS, iOS, Android, tvOS, watchOS, and WebAssembly, and more. .NET 5 is the future of .NET Core and is almost a complete reimagine of the old .NET Framework. In fact, .NET 5 is the first major update since the 2016 release of .NET Core. .NET 5 was a direct evolution from .NET Core 3.1. And the reason why it was called .NET 5 and not .NET 4 is because the last release of .NET Framework was version 4.8, which was released on July 25th, 2019. Both .NET Core and Framework were maintained in parallel, allowing you to choose between one or the other. You could leverage .NET Standard to make shared libraries between the two. The release of .NET 5 meant that .NET Framework will be deprecated. This means you can only use .NET Framework as long as your operating systems, for example Windows Server 2019, will support it. So .NET 5 was the first step forward to unify .NET. And finally, we get to the release of .NET 6. The main significant aspect of .NET 6 is the fact that it delivers the final parts of the .NET unification plan that started with .NET 5. Here is a brief overview of the new features and improvements that we can expect with the release of .NET 6. C# version 10. The significance of version 10 of C# and future versions of C# that are to be released in line with each new version of .NET is that the developer can write less code. With the evolution of C#, there's a strong focus on simplification. Much of the boilerplate code that needed to be written when using previous versions of C# do not need to be written when using C# version 10. So this improves the clarity and simplification of a developer's code and potentially increases productivity, allowing the developer to focus more on application business logic. .NET Multi-Platform App UI for native mobile and desktop apps. .NET Multi-Platform App UI, or .NET MAUI, is an evolution of Xamarin. It allows the developer to create applications for multiple different types of platforms using a single code base. You can write one project that can be compiled into an application that runs on Android devices, iOS devices, Windows desktops, Windows devices, as well as Mac OS. So, one code base written in, for example, C# that can leverage native capabilities on multiple heterogeneous devices. Blazor desktop web apps with native device capabilities. So one advantage of this is that if you are a web developer and don't want to learn XAML to implement your front-end code, as you would when developing an application using, for example, WPF, UWP, or Xamarin Forms, you can use HTML5, CSS, Bootstrap, and JavaScript, i.e., the web technologies with which you are already familiar, to create desktop applications. Through Blazor desktop web apps, you will still be able to leverage native device functionality and not worry about learning new technologies to leverage these native functionalities. Minimal web APIs for cloud-native apps. This is a great feature that allows a developer to be up and coding, for example, a simple microservice a lot quicker than if the developer were to code that microservice using a typical web API that implements the MVC architecture. There is far less ceremony involved in getting started. More device targets, including Apple M1. .NET 6 will support single file deployments for Windows with up to 50% smaller file size. .NET 6 supports ahead-of-time compilation. Productivity enhancements like hot reload. If, for example, you've developed Angular applications with Node, you may be familiar with the hot reload feature. This feature is now coming to .NET developers. This means improved productivity simply because there's less need to stop and start the running of our code during the development of our applications. Continued performance improvements in runtime and build time. EF Core performance is now 70% better on the Tech and Power benchmark. So that was a brief overview of what you can expect with the release of .NET 6. Hi and welcome, I'm Gavin Lon. In this video, we are going to look at some of the great features and improvements that are due to be released with .NET 7. We'll cover these aspects thematically. For more details of what to expect with the release of .NET 7, I've included relevant links below in the description of this video. This video will give you a broad overview of some of the improvements and new features that stand out to me that will be included in the official release of .NET 7, which is due to be released in November of this year, 2022. Since the release of .NET 5, on November the 10th, 2020, Microsoft committed to a new release of .NET in November of each year moving forward. So .NET 6 was released on the 8th of November 2021, and in November of this year, we are expecting the release of .NET 7. .NET 5 was what's known as a current release, and .NET 6 was what's known as a long-term support release, LTS release. Note that there is no quality difference between long-term support releases, LTS releases, and current releases. The only difference is the length of support. LTS releases get free support and patches for 3 years. Current releases get free support and patches for 18 months. At the time of creating this video, the latest preview release of .NET 7 is Preview 6. I've included links below in the description to blog posts that contain details of each of the preview releases of .NET 7. The official release of .NET 7 will be a current release, which means it will be supported for 18 months. The release of .NET 8, due to be released in November 2023, will be a long-term support release, which means it will be supported for 3 years. Preview releases are typically not supported, but they are offered for public testing ahead of the final release. a preview or release candidate release are supported through Microsoft Developer Support only if they're specifically designated Go Live. A brief history of .NET. This channel has released several videos on the history of .NET. The first video I released on .NET is a video on the difference between .NET Framework and .NET Core. I've since released a video on the .NET 5 release and a video on the .NET 6 release. In each video, I've provided foundational content on the evolution of .NET. Please see a link to a playlist below in the description to view the videos released by this channel on the progression of .NET. So in this video, I'll give a brief overview of the history of .NET before we look at the new features due to be released in .NET 7 and also the improvements and optimizations that are due to be released in .NET 7. .NET Framework was released February the 13th, 2002. At the time, it was a revolutionary release for Microsoft as it fundamentally changed the environment in which Microsoft applications run. .NET applications run on what can be described as a virtual machine, similar to how Java applications run on the JVM, Java Virtual Machine. The virtual machine provided in the .NET Framework is known as the CLR, Common Language Runtime. .NET Framework, however, can only run on Windows platforms and requires an installation of all the base class libraries shipped with the .NET Framework. .NET Core was released on the 27th of June, 2016. It is a free open-source managed computer software framework that is cross-platform. It can run on Windows, Linux, and macOS operating systems. Only the base class libraries that are needed by an application need to be shipped with that application, so it is a more agile version of .NET when compared to the .NET Framework. So, .NET Framework and .NET Core is being supported concurrently. This resulted in the fragmentation of .NET. To alleviate this fragmentation, the .NET Standard was introduced. The first steps to properly unify .NET under one umbrella, as it were, came with the release of .NET 5 on November the 10th, 2020. The release of .NET 6 came approximately 1 year later, on the 8th of November, 2021, which shipped with many great enhancements, but most significantly, .NET 6 further cemented the unification of .NET. So, .NET 6 is unified free open source software that is cross-platform and agile. It is an extremely versatile framework in terms of the types of applications that can run on .NET, and the performance of .NET has been optimized for the cloud. It is also versatile in terms of the number of platforms on which it can run. .NET 6 is supported on multiple operating systems: Windows, Linux, macOS, Android, iOS, tvOS, including macOS Silicon and Windows ARM 64. So what is coming with .NET 7? .NET MAUI. There is significant investment in .NET MAUI for .NET 7. .NET Multi-Platform App UI, .NET MAUI, is a cross-platform framework for creating native mobile and desktop apps with C# and XAML. Using .NET MAUI, you can develop apps that can run on Android, iOS, macOS, and Windows from a single shared codebase. .NET MAUI is open source and is the evolution of Xamarin Forms. With the release of .NET 7, you can expect performance improvements and better tooling in .NET MAUI. Cloud native and containers. Cloud native computing is an approach in software development that utilizes cloud computing to build and run scalable applications in modern, dynamic environments such as public, private, and hybrid clouds. So, common technologies used in building cloud-native applications are, for example, Docker containers, a set of platform-as-a-service products that use OS-level virtualization to deliver software in packages called containers. Kubernetes, an open-source container orchestration system for automating software development, scaling, and management. And microservices, a collection of loosely coupled services that run inside Docker containers. There'll be a broad set of investments in cloud native and containers in .NET 7, in terms of, for example, simplifying authentication improvement of performance in terms of startup performance and runtime performance, and better integration with containers. There's also investment in better alignment with the Orleans technology. Orleans is a cross-platform framework for building robust, scalable, distributed applications. Orleans scales with a single on-premises server to globally distributed, highly available applications in the cloud. Orleans uses the virtual actor model, where grains serve as the fundamental building blocks of Orleans applications. Grains are entities comprising user-defined identity, behavior, and state. So with .NET 7, there will be investment in better alignment of Orleans with .NET. Modernizing existing .NET applications. With .NET 7, there is investment to make it easier to upgrade older .NET applications to modern .NET applications. For example, you may wish to upgrade an old ASP.NET MVC application to an ASP.NET Core MVC application. For .NET 7, Microsoft is making investments into its Upgrade Assistant to make these types of upgrades easier. The Upgrade Assistant can, for example, change code written for older .NET environments to be appropriate for modern .NET environments. It will also be made easier to upgrade applications in sections rather than upgrading the entire application at once. There are framework investments for application modernization in .NET 7. Abstractions will be provided that, for example, allow the sharing of parts of the ASP.NET side of the application with parts of the ASP.NET Core side of the application, so the upgrade can be done in an incremental fashion rather than all at once, which may not be a practical solution. .NET 6 contained many performance improvements. Investments are being made in .NET 7 to make .NET even faster and more efficient. ASP.NET Core. HTTP 3 will become part of the .NET framework in .NET 7. HTTP 3 is a new standard in development that will affect how web browsers and servers communicate. Unlike previous versions, which relied on the well-established TCP, HTTP 3 uses QUIC, a multiplexed transport protocol built on UDP. HTTP 3 includes significant upgrades for user experience, including performance, reliability, and security. Minimal API. Minimal APIs are architected to create HTTP APIs with minimal dependencies. They are ideal for microservices and apps that want to include only the minimum files, features, and dependencies in ASP.NET Core. Minimal APIs provide developers with the advantage of less ceremony when setting up Web API applications. They are lightweight. Minimal APIs hook into ASP.NET Core's hosting and routing capabilities and allow you to build fully functioning APIs with just a few lines of code. In .NET 7, Minimal API will be more consistent in terms of what can be achieved when compared to web APIs that use the traditional MVC design pattern. One new feature in .NET 7 is providing a way to group minimal APIs together with a common root prefix, so that they represent one part of the API space, as it were. A developer can take the APIs and put them in different files, so that it is more manageable from a project and code management perspective. Currently, you can apply action filters to controllers in a Web API component. The ability to implement such code for cross-cutting concerns will now be available for minimal APIs. The concept of endpoint filters will be available in .NET 7 to apply the same cross-cutting functionality that, for example, action filters provide for controllers. gRPC. gRPC was created by Google to speed up data transmission between microservices and other systems that need to interact with each other. With .NET 7, there is investment in gRPC JSON transcoding. The feature allows gRPC services to be called like RESTful HTTP APIs, with JSON requests and responses. So, for example, this will make it easy for JavaScript code running within a browser to call a gRPC service. SignalR. SignalR is a free and open source software library for Microsoft ASP.NET that allows server code to send asynchronous notifications to client-side web applications. SignalR was built for high performance and is one of the fastest real-time frameworks around. In .NET 7, there will be support for strongly typed clients and returning results from client invocations. A new client source generator for SignalR will be included. The SignalR client source generator generates strongly typed sending and receiving code based on interfaces that the developer can define. .NET 7 will come with various improvements to the Razor compiler to improve performance resilience and to facilitate improved tooling. Blazor. Broad improvements will be made to Blazor. For example, mixed mode AOT, ahead of time compilation, will allow for certain assemblies to be ahead of time compiled rather than the entire application needing to be ahead of time compiled. When ahead of time compilation is implemented, this makes the overall size of the application to be downloaded to the browser much larger. So although runtime speeds are increased for the application, the file size is much larger. Enabling mixed mode means that parts of the application can be optimized for speed. Those parts of the application that require greater speed can be ahead of time compiled, leaving the rest of the application to be interpreted. So speed can be increased where it counts, and a balance is maintained between less size of the application and the benefit of speed optimizations. Most browsers are now capable of facilitating multi-threading, so .NET 7 will take advantage of this and will provide multi-threading to Blazor WebAssembly applications. Web crypto simply means that cryptographic functionality available in browsers can be leveraged from Blazor applications. With the release of .NET 7, there will be enhancements in hot reload support, data binding improvements, more flexible pre-rendering. Pre-rendering Razor files into HTML allows parsing of static files, which, for example, makes SEO, search engine optimization, effective in Blazor applications. More control over the lifecycle of Blazor service circuits. Improved support for micro front-ends. Micro front-ends are a new pattern where web application UIs, front-ends, are composed from semi-independent fragments that can be built by several teams using different technologies. Support for custom elements is an exciting feature where you can shrink wrap, as it were, a Blazor component in a standard custom HTML element. This means you could reuse the relevant custom element created in a Blazor application within, for example, an Angular or a React application. So that's a super exciting feature. MVC. .NET will include improvements made to endpoint routing, link generation, and parameter binding. Orleans. The ASP.NET Core and Orleans teams are investigating ways to further align and integrate the Orleans distributed programming model with ASP.NET Core. Orleans 4 will ship alongside .NET and focuses on simplicity, maintainability, and performance, including human-readable stream identities and a new, optimized, version-tolerant serializer. This video provides a brief overview of some of the features and improvements to expect with the next official release of .NET, which is due to be released in November of this year. .NET 7 will be a current release, meaning it will be supported free of charge for 18 months, and will contain many great new features, many performance and optimization improvements. With this new release of .NET and the commitment to release a new version of .NET every year moving forward, makes it a great time to be a .NET developer. If you liked this video, please give it a thumbs up, and please feel free to share this video with anyone you feel may benefit from its content. For content like this and much more, please consider subscribing, and please ring the bell so as to be notified when new content is released. I really enjoy reading your comments, so please feel free to leave a comment below in the description. I hope you've enjoyed this video. Thank you, and take care.